So I'm going to record this so other people can watch it. Now let me play so the class can watch. All of my recordings are with an awkward, like, let me share screen, let me do this. It's very awkward. Oh, thanks, Grace. Okay. I'm using all my cords. Sorry, Lex. Okay, so we all see what I have on the board? Perfect. We are on P4 today, so we're going to see what we can do. Make sure if you're not actively eating or drinking, put your mask back on. I know it's the end of the day. I know it's been a long day, but let's be as fast as we can. We did number A, right? Can someone remember or remind me how to do A? What's going on there on letter A? Yep, Laura?
Y2 minus Y1 over.
Good. We're all getting started. I hope everybody's with me. You guys already did letter A, so we should have solved that. But remember the formula for slope is Y2 minus Y1 over X2 minus X1. Did I tell you guys, remind you it was rise over run? Yeah. Perfect. All that fun stuff. So let's do it for AB as well. So I've got on letter B, I've got 2 more points. Let's do my slope of those. X1, Y1. My iPad's doing some funny things, and I don't know if it's a personal problem or what, but we'll find out. All right, so slope, Y2 minus Y1, X2 minus X1. Got something funky here. What's going on? What's my slope? 0. Why is it not undefined? I thought undefined was when there was 0. Whitley, remind me, it's okay. If 0's on top, it's okay. It works. It's 0. If 0's on the bottom, do we have a saying for that?
No.
N-O. Oh, I should have had an N instead of a K. I was like, oh, is that something we were supposed to know? N-O is undefined. I am all here for whatever little tips and tricks help you remember something or do it correctly. So, okay is fine, and then N-O is not good. It's undefined. All right, so if you can't tell already, this whole section is on lines, slopes, etc. So we got to remember all of those formulas. I'll try and highlight them as we go. So here's slope in case I need to remember it or recall it again. The next one says find B so that the slope of AB is as indicated. So I know that A is 0.32, B is 0.6 comma Y. We don't know what Y is. And then my slope is 2/3. Any ideas on how to set that up? And then my equation. How should I label my points? Does it really matter? No, I'm just going to go left to right. So I'm going to call this one X1, Y1, X2, Y2. There's no like trick for that, or like you can't do it wrong just as long as you're consistent with how you do your points. So I'm going to do Y minus 2. So that's my Y2 minus Y1. And then I'm going to do 6 minus 3 for my X2 minus X1. Then simplify as much as you can. When we can't simplify anymore, we're going to cross multiply. So the denominator can become 3. 2 over 3 equals Y minus 2 over 3. Cross multiply. I want you to hold that thought because I think that's a point I want to make in 1 second, Laura. So I cross multiply and I get 2 times 3 equals 3 times Y minus 2. 6 equals 3Y minus 6. Add 6. This is a very narrow space. I'm running out of space. 12 equals 3Y. Divide by 3. Y equals 4. Just simple solving. Okay. I told Laura to hold because I think she's about to make a really interesting point. Laura, what did you want to do? So Laura from this step right here was like, well, they're both 3 in the denominator, so shouldn't they both be 2 in the numerator? If these denominators are the same, yes, you're definitely allowed to do that. So then you can just think, oh, the denominators cross each other out, and I'm just left with 2 equals y minus 2. Oh, God, okay. I couldn't write that for the life of me. And then you would solve and get the same answer. So yes, exactly. I did go all the way out just in case you have to in the future. You don't always have the numbers to be the same, but that is a great shortcut, Laura. Yes, way to point that out. Anything else on this problem?
So it only works if the bottom is the same.
Yes. Only works if the bottoms are the same. All right, same idea for the next one. Can you try that on your own? Can you say that? Try the next one on your own. As you're working, you can check up and see what I'm doing to make sure you're on the right path. I'm just checking my work. Does that look good to you guys? Okay. So if I give you the slope and then give you a completed point and then a not completed point, we can just use our slope formula in order to solve. Okay? Not too bad. Next, it says write the point slope form of a line. Wait a second, what's point slope? Who remembers point slope? Most of us remember slope intercept. Don't write this down yet. Let's walk through this. So this is what you've said so far. Okay. Good. The only thing I'm going to change, Laura, is I don't want that 2 in front of that first x because I do want variables x and y just by themselves. And then we're just going to plug in 1 point. So the cool thing about point slope is it has a point, it has x and it has y. So a point x1, y1, and then it has the slope. And so you can use just that information in order to plug into point slope form. We do keep 1x and 1y without any subscripts, without anything crazy, because I want those as variables to stay with us the whole time. Okay, so let's do that. So I don't want you to simplify or anything. It says point slope form, that is this form. Don't go all the way to slope intercept. Don't do anything crazy. Literally plug in and leave it. So what I'm going to do for this first one is I'm going to do y minus y2 or y1, x1, y1. Why are you being like this? So I'm talking to the iPad. Slope is m. So I've got y minus y1, which is 2, and then that equals m, which is 6, times x minus x1, which is 6. Yep, I haven't done that yet. Yes, thank you, Ava. Minus minus becomes plus 2. And that's as simple as it gets. X plus 2 equals 6 times x minus 6. I don't want anything else. period, the end. Try the next one. Oh, is that not good? Wait. Oh, I don't need to say that. It was redundant, like writing 1x. Okay, I'll remember that. Good thing you guys are here to keep me young. Oh, Lex. Oh, shoot. The next one has an extra step. What do you have to do for the extra step? Find the slope. Do you have to use one point or the other when you solve it? Nope. You might use -2.5 and your friend might use 4.17. It doesn't matter. It's the same thing. Find the slope for me and then plug into point slope form. All right, you should have one of these two equations. Thumbs up, we good? Signs of life? Thank you. Like 4 people alive in here. Awesome, there we go, there we go. Signs of life. All right, moving on. The next one says we're gonna write with pointed slope form a line that's parallel to x plus 4y equals 10 and contains the point 1, -1. Okay, there's a lot going on there. First thing I need to know is what do parallel lines, what do their slopes have in common? What are they, how are they related? Allie? They're the same. So if I can find the slope of this line that's given to me, I'm just going to use that exact same slope in order to do my next problem. And how do I find my slope of this? What? Anybody say something? It's the m, yeah. We got to do something though in order to get m.
When you plug it into the y and the x, then the full slope is.
Not necessarily. Willie, what did you say? Yeah, put it in, I heard someone else say slope-intercept form. Let's get it into y equals mx plus b, solve for y, and then whatever number is in front of x is your m, like Grace said. We want m, but there's this number in front of y, and that's going to make my m funny. So let's solve it all the way over, y equals, and then we'll be able to solve from there. So to solve for y, this is kind of what we practiced yesterday, but we practiced with a bunch of variables, and it was kind of messy. So we're just going to get y by itself. Minus x from both sides. 4y equals -x plus 10. Divide by 4 from everything. I don't even care what a y-intercept is about to be. So I'm going to say y equals, I know it's going to be -1/4 x. And then I really could care less what's over here. So I'm just going to leave it as 10 over 4 because it doesn't matter. From here, I know that technically the number in front of x is -1. We just don't write 1 because it's redundant. And then it's underneath 4. X being on top is the same thing as being multiplied by that fraction. It's like x over 1 here. Okay. So I can split it apart like that. Good question. Awesome. So I'm going to use the slope of -1/4 right here. That's my m. And then this is my xy. And so now we get to plug it into our equation. Y minus -1 or y plus 1 equals -1/4 parentheses x minus 1. All right, good so far? Keep rolling. Next one says perpendicular to a line and a point. How is perpendicular different? Opposite and reciprocal. I'm actually going to make a note of that. I didn't do that earlier. Let me make a note of that because I might forget it later. Parallel is the same slope. And then I'm going to say, I'm going to zoom in so I can write kind of nicely, and then I'll zoom out so you can read it. Perpendicular is opposite reciprocal slope. So just some keywords for myself. So we're going to do the exact same thing, but instead of just using the slope I see, I have to do the opposite reciprocal of it. Can you start it for me? Yeah, you guys can start on your own. What'd you say? Whoa, that's awesome. Is that that, I remember we talked about this last year. It does start with an S.
I know you.
Oh no. I almost said Stillman, but that's not right. I'm close. Oh my god, it's gonna come to me halfway through class. Let me hold tight. I'll ask again at the end if I remember it. I know what you're talking about. I just can't remember it. Going crazy. But that is awesome. I think a lot of schools are doing that. So I know that last year some schools already had said that because like you guys were, it's not normal for a junior to take the SAT before March. And so most of you were probably scheduled for that March date, weren't you?
Yeah.
And then you didn't take it, and then we couldn't take it for months. And now are all of you like signed up for this weekend? Yeah, or some of you. And so now it's like this should have been like your second or third time taking the SAT, and it's only your first time. So I think a lot of colleges are doing that, or many even before this were testing optional. So if you tested, you could send them your scores, and it could help you, but it's not going to hurt you or hurt your chance for getting in. So that's good. Yeah. Come on. All right, I'm going to talk my way through this. If you're still going and you don't need my help, awesome. If you do need my help, listen up. I need to get y by itself, so I'm going to do minus 2x. So negative 6y equals negative 2x plus 8. Divide by negative 6. Negative 2 divided by negative 6 is 1 over 3. And then I don't even care what this is over here. I'm just going to leave it as 8 over 6. Doesn't matter. I'm not going to graph it. I don't care. So the point or the slope that was given to me here was 1/3. But I need to do the opposite reciprocal. So what would that be? Negative 3. So that's what I'm going to use. And then I only have 1 point. So that's my option. So y minus 7 equals negative 3. X plus 3. Oh, I ran out of space. Oh, that's garbage. All right, moving on. Now we're on slope-intercept form. What's that? Y equals mx plus b. I heard it from someone. Thank you. I've got a couple of things to highlight. I've got my slope-intercept. I'm going to go back and highlight my point-slope form if I hadn't already. I'm going to erase all that nonsense on it. And my slopes. We've got 3 formulas essentially today. All right. Do I need to walk you through this, or do we want to try it on our own? I'm good either way. Want to go together? Walk together? I like to start as many of these as I can with point slope and then manipulate it so that it is slope intercept form. So for this one, I have a point. I've got x1, y1, and I have a slope. So I'm going to plug it into point slope. Y minus 8 equals 6 times x minus negative 5 or plus 5. And then from here, I'm just going to get y by itself. So I'm going to distribute my 6 and then move my 8. A big mistake we make as freshmen and sophomores when we first learn this is you want to move the 8 over first and then you try and play around. No, no, no. Leave that 8 till the end. Wait till the end to do it. So this becomes y minus 8 equals 6x plus 30. And then I add 8 to both sides, 6x plus 38. Is that what you guys got? Yeah. All right. Let's keep rolling. Next one, now it says through these points, 0, 3, and negative 4, 0. So we got to figure out what slope is first. Slope, x1, y1, x2, y2, m equals 0 minus 3, negative 4 minus 0. Three-fourths, thank you. Where'd the negatives go?
Away.
Perfect. Oh, flex, away. Yes, they do just cancel, so they're gone. Slope is 3/4, and then it doesn't matter which point you use. I'm not going to do it both ways because I don't really feel like doing it 2 different ways. We'll just do it one, and then you'll be able to check your answer because slope-intercept will be the same no matter which point you use. Let's do y minus 3 equals 3/4 x minus 0. You can think about it as distributing, or you can just know x minus 0 is just x. So I'm left with y minus 3 equals 3/4 x. No, don't let me write it like that. Sometimes I like to write like the slanted fraction mark, but then I get confused on where x belongs. So I like the straight across fraction mark so I don't get confused. X is next to it, not on the bottom. And then add 3 to both sides, so I get y equals 3/4 x plus 3. Okay. Now I've got parallel to and through and perpendicular to and through. So again, do I need to solve this parallel to out? Why not, Becca? Yeah, and what is the slope? 2/3. That slope is not going to change if I multiply or not. I'm just going to keep it there. That is way less work for me. Awesome. M, x1, y1. So I've got y minus negative 2 or y plus 2 equals 2/3 x minus or minus a negative or plus 4. Going to distribute through. Y plus 2 equals 2/3 x plus, 2/3 times 4. Let me do that off to the side. Remember, that's the same thing as multiplying 2/3 times 4/1. There's nothing to cancel here. I would have to look left and right. Essentially, I'd have to look across the diagonal this way. Oh, you can't see everyone. You would do the wall. I have to look this way, 2 and 1. That's as simple as it gets. And then I have to look this way, 4 and 3. That's as simple as it gets. I look a catty corner to see if I can cancel, but then I multiply straight across either side. 2 times 4 is 8. 3 times 1 is 3. That can't be simplified, so that's as good as it gets. So I'm going to do 8/3 over here. And then I have to minus 2. Yuck, more fractions. Y equals 2/3 x plus, and let's figure out what goes there. So I know I have 8/3. We're going to need, in order to do 8/3 minus 2, I need to make 2 a fraction with a common denominator. What should my denominator be? It can be smaller. It can just be 3. So think of this as 2/1. I drew it kind of low and ugly, but think of this as 2/1. So in order to get 3, I'm going to multiply by 3 on top and bottom. Maybe that's what you were thinking, Lex, with the 6. So I've got 8/3 minus 6/3, and that's equal to 2/3. Again, just because I think that you forgot everything over the summer, remember with fractions, when you add or subtract, the denominators don't change, just the numerators do. When you multiply, that's when the denominators change too. So 2/3 goes in this box right here. And so my final answer, oh, it's a lot of 2/3s. Y equals 2/3x plus 2/3. All right, hanging in there so far? All right. Let's do perpendicular to. Perpendicular to 2x minus 4y equals 9. And through the point 1, 2. Gotta find our slope. Solve for y. We've got -2/-4, which is 1/2. I don't care what that number is. So my slope is going to be what? -2. You guys can't be tricked. And my point is 1, 2. Y minus 2 equals -2, x minus 1. And then distribute. Y minus 2 equals -2x plus 2. Add 2 to both sides. Y equals -2x plus 4. How are we doing with that? Good? All right. We're going to keep rolling, but the next little bit says book problems. I got to get the book up on the screen. I'm going to be really honest. I haven't had any time to think about your guys' textbooks. Since I've been giving you guys these sheets and all the homework, it's just not been a priority for me. I believe there's a link to it. If not, did I tell you there's like people have been passing around like a PDF version? I don't know who might have that to give to you. I would ask around if anyone took PreCalc last year. See if they have a book. You have it, Ava? Ava has it. Maybe if you're nice to her, she'll share with you. I have it on here, so let me see if I can get it up. So Zoomers, I'm going to stop sharing this with you. You're just going to look at my face for a second. Let's see. Oh, where would I put it? Oh, here it is. Nope, that's not it. Mm-hmm.
What? I don't need it. Well, actually, do you need it? Yeah.
Ava was so confident. I don't need it. Okay, maybe it's on my Google Drive. I don't know. I know I have it. I just haven't accessed this book forever. And I left the textbook at home. Let's see.
Wait.
How many?
Can you do it again? I did it for you.
Well, I really should have found this before this class. And I have. Please do. Anybody go. It's a free for all. Anybody go if you need to go. Okay, I'm gonna do this. I need to turn my AirPlay off so I don't know what's gonna come up on the screen. Say again. Oh, okay. I thought you were talking to me. I'm like losing it over here. My hard drive gone. Oh, now my internet doesn't feel like working. Sorry, Zoom, you might be gone. All right, I found it. I'm downloading it. We're getting there. Okay. All right, so did I say what page we were on? Page 41, number 45. Okay, I do know that depending on what PDF you guys have, it may not be the same page numbers. So that was something that was an issue last year. I'd say like homework is on page like 13 and they'd be like, well, that's textbook stuff. And I was like, well, just go to like P1 or whatever it was. So I'd say section number. So let me see what number 41 looks like and then it might be okay. Okay. Yeah, my 41 doesn't have 45, etc. on it. So we're going to make sure that we're on P4. And we're going to do the book problems that say, yeah, 45. Okay, perfect. I guess we're doing some investment planning. I did not do these problems beforehand, so this will be fun. This will be relevant though. Just like personal Miss White story, I bought a house last summer and the rates of loans are really low right now. And so I'm working to refinance my home for a less amount of time. So when I'm on like a 30-year mortgage right now, so you have to pay over 30 years and there's like a interest rate that goes with it. So like a lot of right now I'm paying interest and I'm not paying off a lot of my loan. If I get it to a 15-year mortgage rate, then I pay it off in less time and there's less interest. So it's like a very real life situation that you guys may have to do if you buy like a car or have student loans or something like that. Interest is ridiculous. You pay so much interest, it's stupid. That's how I feel about it. And again, I am not like your, I'm not an economics teacher. I'm not a financial advisor. Like I'm nothing. But what I'm saying is like, this is what I am experiencing right now. And I think it's really cool to talk about it. Now we're doing this linearly, so it's not necessarily the same as what I have on mine, but it's good to know. Okay. I think I've shared for Zoom. Do you guys see my screen on Zoom?
Yes.
The textbook problems?
Yeah, I think so.
Perfect. Okay. I'm going to share that with the rest of the class. Awesome. Okay. I've been recording this whole time that I've been searching for this document, so that'll be fun. I'll also watch the YouTube later. Oh, God. Never a dull moment, guys. All right, let me make this a little bit bigger because I can't read that. So, ooh, too big. I got a little too excited. Okay, so number 45, it's a real estate problem. And it says, Bob Michaels purchased a house 8 years ago for $42,000. Also, that's nothing in houses. That's ridiculous. You can't buy anything with that much money, with that little money, we'll put it that way. Again, that was a rude awakening when I was buying a house. Houses cost a lot of money. Anyway, I digress. This year it was appraised for $67,500. A linear equation V equals MT plus B. What do you think T stands for? Time. Great thought. T is time. And then we don't know what M and B are. Let's see if it tells us. V represents the value of the house for 15 years after it was purchased. Determine M and B. So let's see. Can I switch what I'm sharing? Can I do a, let's try this. I'm gonna get a little crazy. Okay. Now you guys see grade books. That's not really great. Okay. Let's make this guy smaller. And let's make this guy smaller. And let's see if I can put them side by side. I'm just gonna have to zoom in. All right, Zoom people, do you see both my iPad screen and the book problems?
Yes.
Perfect, and then we see that too up here. Okay, this is even easier. Awesome, so we are using the equation. So we're doing little letter A, and it says V equals MT plus B. Let's see, we found out that 8 years ago, it was $42,000. And today, so that would be 15 years later. Oh no, today is, I'll just write now for right now. And that will be 67,500. We don't really care what M and B are. We're about to find those. But what we do know is we know that in terms of years, you told me that's T. And then big V represents our value of the home. So what we're about to do is have coordinate points. We're about to have T comma V for all of these. We're going to make all of these into T comma V's. Now, I know I wrote 8 years on the first one. Let's treat that as like 0 years. So let's say that you bought the house at 0 years. Then that would make now how many years later? So that would be 8. So my first T is going to be 0 at 42,000. And then the next time is going to be 8, 67,500. If we have those 2 points, we're allowed to find slope between them, right? That would find my M. We can just go back calling these x1, y1, x2, y2. And then we would solve. I'm just going across. I'm afraid I'm going to run out of space because I write kind of big. I'm going to take those 2 points I just found. I'm going to put them in for my slope. M equals 67,500 minus 42,000 over 8 minus 0. I know it's 8 on the bottom. I don't know if I'm not good with math in my head today. $25, $50. Yeah, thank you. And then divide that by 8. I'm okay with a decimal here because these are such crazy numbers. We will let this slope be a decimal. If it's a normal problem, then we do not want any decimals. But this is my change essentially. This is basically saying that every year, so in 1 year and 1 T, then it increases this 3,187 I can use this and plug this into my equation with one of my points and find out what B is. I'm going to do the 0 point with 42,000 because 0 is one of the numbers and I don't have to do any more math. So I'm going to do y minus 42,000 equals 3,187.5 times x minus 0. Funky 8 I've got going on there. Distribute, we're going to move our 42,000 to the other side momentarily. 3,187.5x plus 0. And then move your 42,000 over to the other side. Y equals 3,187.5x plus 42,000. Which makes sense. That's where we're starting. At 0 years, they're starting, it would look like this for you guys. They're starting here and we're going up over time. It's increasing the value of the house. Okay, then it says graph the equation and trace and estimate how many years after purchasing this house will be worth 72,500. Do you have our calculators? Anybody have their graphing calculators? Let's get that out. If we do it by hand, there's only so much estimating we can do. So let's do it on our calculator. We're going to graph this equation right here. Y equals 3,187.5x plus 42,000. And then we're going to be able to see where my y, I'm going to know like what's my t value, t equals what, when my v is equal to 72,500. So I'm going to get my calculator up. I'll go back to my screen in a second. Sometimes it takes a minute to open. Whenever you're ready, calculator. Ah, here it goes. Not today. All right, so I'm gonna go to y equals. I have no idea what I was plotting before this. I'm gonna do 31,800. Nope, that's not right. 3,187.5 times x plus 42,000. Now, I would bet money most of your graphs are at -10, +10, and +10, -10, right? Do we even need any negative numbers in here? Nope, but we're gonna need some big numbers. So we're trying to get up to 72,500 at least. So I would maybe put your y max at 75,000 just so we can make sure that we get it. You can put your y min either at 0 or at 42,000. That's why all you'll see is the graph. And then our time has gone between 0 and 15. So in your calculator, your x min should probably be 0. Your x max should probably be 15 because those are my years. My y min should be either 0 or 42,000. And my y max should be like 75,000. So before I even look at the graph, I'm going to go to window. And I'm going to do that. 0, 15. Nothing else should really change. 0, and then 75,000. Any question on how I decided that was my range? I didn't want to go to my graph immediately because I knew it wasn't going to fit. I'm looking at really, really big numbers, so I want to automatically go there and see what I've got. Awesome. It's even a little bit off my page. That's okay. How do I find what my T should be when my V is 72,500? So again, you could do intersect. If I do intercept, then I'm going to do a y equals and put my 72,500 there. And then we will see where they cross. Ooh, right there at the top. In order to do an intersect, I need to have two different lines so that I see where they cross. So one of them was the slant, that was my value of my house, and the other one is how much I wanted it to be at. I go to second trace and go to intersect. How comfortable are you guys with the calculators? Comfortable enough like to do this? If not, then we'll have to work outside of class, and that's totally fine.
Okay, thank you.
Let me know, we'll set something up. I have to do one line, enter, other line, enter, and then I scroll to where I think that they connect at. Enter. And so it says it's at 9.568, 9.56, or about 9.6 years. Y2, I put this 72,500 because that was the goal of what I wanted. Good question, Al. All right, next part, C says write and solve an equation algebraically to determine how many years after purchase this house will be worth $74,000. Do I need to find a new B or new M? Did it say anything about my value changing? Nope, those numbers are still applicable. Where is 74,000 going to go in my equation? Is it going to go for V or is it going to go for T? Is it a time or is it a value? Value. So it's going to go for V. So to do letter C, I'm going to do 74,000 equals, and then everything else is the same. 3,178.5x plus 42,000. Since the directions use the word algebraically, I don't want you to use a graph on this one. We gotta do some calculator stuff. Well, I got about 10 years. And then letter D says, determine how many years after purchase this house will be worth $80,250. Cool, numbers are hard today. Is that any different than what I've been doing? Nope, it does not specify graphically or algebraically, so you can do whichever one you want. If you want to put 80,250 in for your Y2 and find where they intersect, or if you want to do the algebra like we just did, it's up to you. I'm probably just as comfortable with the algebra, so I'm going to do that. This time, instead of 74,000, I'm going to do the new value, 80,250. Come on. There you go. Let me find it really quick. 250 minus 32. And I think that's 12. Is that what anybody else got? Perfect. Okay, I am going to stop record. Oh, I don't know if I was recording this. Did I record this? Am I going crazy?
I think you said you recorded it.
Yes, okay, stop recording.